We're going to continue with calculus. This is the fourth set of calculus. We're going to look at tangents and normals again. In essence, we're sort of getting our hand in at practicing doing differentiation, first derivatives, second derivatives, finding slopes of lines, etc., and recognizing what the derivative actually stands for. Let us continue and do another example. Because I remember saying that fundamentally you just got to do examples with these and that's that. And here they say find the equation of the, guess what? Any guesses? Yep, tangent and normal to the curve. I'm just going to put 2x, y equals 12 at x equals 2. Normal tangent, trigger words, meaning what are we going to do? We're going to take f prime. But now we've got x, y equals 12. We don't have f of x or y. It's not in the standard form, is it? You put into standard form is y equals. So therefore y is going to be equal to 12 over x. Therefore, dy by dx, I have to change that to 12x to the minus 1. Therefore, dyx is going to be equal to 12 times minus 1, x to the minus 1 minus 1, minus 12x to the minus 2. I'm going to just take it to standard, 12 over x squared. That's my dy by dx. That's f prime, and I leave it at that. This is the slope at any point to the slope of the tangent. Sorry, my bad. Slope of the tangent at any point to the curve. Right? The slope of the tangent at any point to the curve. Now they have given us the point, and the point they've given, they have told us that they wanted at x equals 2. Therefore, now we're going to be looking at the tangent. Right? They want to know at x equals 2. Then we say, right, m is equal to minus 12 over 2 squared, which is going to be equal to minus 3. Then the next step is we say it is always, remember this, it's always a straight line, therefore y is equal to mx plus c. And we say, cool, then we go and we say, right, y is equal to minus 3x plus c. Now I need the contact point. The contact point I work out by saying x equals 3. What is y? And I go back to my original equation, y is equal to 12 over x. So it's going to be 12 over 3, which is 4. Therefore, my contact point is 3 and 4. Pretty straightforward. Next step is we put that back in and we say then 4 is equal to minus 3 times 3 plus c. This is going to be minus 9 plus c is 4. Therefore, c is going to be equal to, wait, 3, 4. Oh, Kevin. It's y is equal to 2. Sorry, my apologies, guys. I was looking and saying this is not right. I'm sorry, it's at x equals 2. I misread it. Please accept my apologies. It's at x equals 2. That's going to be 6. So my point is 2 and 6. I do apologize about that. I just had 3 stuck in my head while I was going for it. So, and you just get the feeling from the numbers that it just looks a bit weird. So I'm going to say minus 3 times. Just let me tidy this up. It's going to be minus 3 times 2, and it's going to be a 6 on this side over here. So it's going to be 6, and it's going to be 6 over there, right, like that. And we've got, therefore, is minus 6 plus that. Therefore, c is equal to 12. Now I can write down the equation of the tangent. The equation of the tangent is y is equal to minus 3x plus 12. And we're going to do the same again. They want to do the normal. So I have a special, and once again it's a straight line. Y equals mx plus c. What do? I write m of the tangent times m of the normal minus 1. M of the tangent is minus 3 times m of the normal minus 1. Therefore, m of the normal is going to be minus 1 over minus 3 is 1/3. And therefore, the equation of the normal is y is equal to 1/3. There we go. That's the m times x plus c. Then I use the contact point. Correct? I use the contact point and I say, therefore, y6 is equal to 1/3 times 2, okay, divided by, okay, plus c. So that's going to be 6 equals 2/3 plus c. And you can see these generally end up as a fraction. So c is going to be equal to 6 minus 2/3. And the final answer comes out to be 16/3, which is 16/3. Therefore, the equation is y is equal to 1/3 x plus 16/3. 5 and a bit, right? So that brings us to that. The next question is, they've given us another example is they've given us two parabolas. And they've said these two parabolas do this. All right? You're going to see this one a few times. And they want to know, remember, x is along this way, right? We don't know where these are, but the x-axis is that way. And they have told us that this is g of x and this is f of x. And they tell us that g of x, or rather let's put f of x, is equal to minus x squared plus 2x minus 4, and g of x is equal to a half x squared minus 3x plus 2. Right. Then they've said find x for which the tangent to f of x is parallel to the tangent to g of x. Right? What does that mean? F of x is that way and this way. Now you can see as x moves on, okay, let's say x is in here somewhere. All right. As we move on, we get points, and you can see the tangent. At some point, these tangents become parallel. So we have to find where this point is. How do we do it? They're talking about tangents, therefore it must be derivatives. So I say, what's the derivative of this one? The derivative of this one over there is going to be equal to minus 1 times 2 times x to the 2 minus 1 plus 2 minus 0. So f prime x is going to be equal to minus 2x plus 2. What about g prime of x? This is the other one we've got. So I'm going to find the derivative of that. And that's then going to be g prime is going to be equal to a half times 2 times x to the 1, correct? Minus 3, which is then going to be x minus 3. Now they've said that they must be parallel. Let's go back up here. What do they mean when they talk about it being parallel? They mean m and m. M must equal m2. To be parallel, the gradients must be the same. So what I've got here, what is this? This is the gradient at any point x. And this one is the gradient at any point x. So what do? I put them equal to each other because they must be the same. Therefore, to be parallel, the gradient m1 must equal m2. Right? The gradients must be the same. So I say minus 2x plus 2 must be equal to x minus 3, which then gives me minus 3x must be equal to minus 3 minus 2 is minus 5. So x must be equal to minus 5 over minus 3, which is 5 over 3. Correct? So that's my answer. Simple and straightforward. Always remember, if they talk parallel, it means the gradients must be the same. And when you've worked out what the gradients are for both curves, you just put them equal to that. Not much one has to remember on this, really. Then my next one is another example, all right? Example, we're going to rip through quite a few examples, but I think it's important. Examples. Find the value of x, okay? So find the value of x. In other words, they mean the x coordinate. That's what they're saying, is it not? Find the value of x where the tangent or tangents to y equals 2x cubed plus 3x squared minus 12x. Let me just tidy that up there. Minus 12x plus 2, okay, are parallel to y minus 10x minus 3 equals 0. Okie dokie. Find the value. So I'm looking for an x coordinate. I'm looking for an x coordinate on this one that gives me a slope the same as that. So it must be parallel to this line. This line is non-standard. Therefore, you write it as y is equal to 10x plus 3. Therefore, the gradient m of this line is 10. That's the slope of this line. Is it not? That's the slope of this line. Is 10. Then I've got a y over here, y equal to 2x cubed plus 3x squared minus 12x plus 2. Now I've got to find dy dx of this. Why do I do that? Because that's y, not f of x. Is going to be 6x, that's squared, so it's going to be plus 6x minus 12. Correct? 6x squared plus 6x minus 12. This is the slope at any point x. That's what I'm looking for, is that x. I'm looking for the slope at that point. And I know that the slope must be equal to 10. Therefore, 6x plus 6x minus 12 must be equal to 10. Correct? I take that over and I say 6x plus 6x minus 22 must be equal to 0. It's a straightforward quadratic equation, and I get that x, okay, use a calculator or the formula, whichever method suits you, and you'll find that x is, the roots are going to be minus 3 plus or minus the square root of 141 over 6. Then x1 is going to be 1.479. I think that's 1.8. The other root is minus 2.48. And they have told us that, and therefore Right. We now can easily, well, that's actually the answer, is it not? Let's just go back. That's the values of x. So at this point and at that point, you've got two tangents. Right. So you can go and you can now work out what y is, and you can find the equations of those tangents. That wasn't what we were asked in this question, but I think we've done plenty of finding equations of tangents by now. Right. Now I'm going to say here, another example. Here we are given, this confused quite a few students. Y equals x squared minus 1 minus yx. Now that's not standard. We have got a problem here. That's cool, but what about this here? That's kind of like no-go. How do we deal with this? Remember we said before we differentiate, we always simplify. But we have to here simplify and make y the subject of the formula. So therefore y plus yx is going to be x squared minus 1. Factorize 1 plus x equal to x squared minus 1. Therefore, y is equal to x squared minus 1 over 1 plus x, which is, the top is difference of two squares. X minus 1, x plus 1, all over 1 plus x, and that is the same. Therefore, y is actually equal to x minus 1. Okay. Now, given that, all right, and, okay, they said find dy dx. Find dy by dx, and it's going to be equal to 1. And note, y was equal to x minus 1. What is the slope? It's m is 1. So they actually agree with each other, which they should. Okie dokes. The little trick there was to do the simplification to get it all to the other side, factorize and divide through by. As I say, a couple of students asked me that one. So I thought because it was different, I'd just pop it in there. Then there's another example. I know we've done a load of examples of this. Another example is given f of x is equal to 4 over x. And y equals 4x plus 15. As the equation of the normal in the third quadrant. Okay. In the third quadrant. Find the contact points. Find the contact points. Obviously, the one on top or the one is a hyperbola, is it not? And the other one is a straight line. So how do we find where two graphs intersect? Put them equal to each other. Therefore, I say 4x plus 15 must be equal to 4 over x. Find x. Oh dear. How do we do it? Can anyone remember? We multiply through by the x, correct? Which gives us, this is times through by x. So we get 4x squared plus 15x is equal to 4. 4x squared plus 15x minus 4 equals 0. Why do I do that equal to 0? Because it's a trinomial, quadratic. No, I can't factorize x and put them both equal to 4. That does not work. I have to get it into quadratic format. So what do I say? I then say, okie dokie, I factorize this, and I must be honest, I factorize this with a calculator, and I'm just going to write the answers below. I got x equals a quarter, and x equals minus 4. x1 and x2 is what came out of my calculator, and it gave me those numbers. Okay. Therefore, subs in to find y. Therefore, if I put x equals a quarter, y is equal to 4 over a quarter, which is equal to 16. So my contact point for the first one is going to be x is 4, y is 16. And the next one I say y is equal to 4 over minus 4, which is equal to, let me tidy that up a bit. Oops, that's not going to work, is it? Looks like a horrible signature. 4 over minus 4 is minus 1. Therefore, I've got minus 4 minus 1. Okay? And I say, which is in quadrant 3? This is in quadrant 3. Therefore, this is the one we use. They told us it's quadrant 3 that we have to use. So then they say, find the equation of the tangent. Okay? Part 2 is find the equation of the tangent. Obviously, I've got m of normal times m of tangent equals minus 1. The m of the normal, in this case, was 4 times m of tangent is minus 1. Therefore, m of the tangent is minus a quarter, and the tangent is y is equal to mx plus c, which means y is equal to minus a quarter x plus c. And what do I use here? Use the contact point. Okay, pretty much wash, rinse, repeat, right? So I'm going to say minus 1 is minus a quarter times minus 4 plus c. C comes out to be equal to, if my calculations are right, subs minus 2. Because that's going to be equal to plus 1, yes. So minus 1 is equal to 1 plus c. C is minus 2. My equation is therefore, ta-da. Let me continue and put the equation. Y is equal to minus 1 quarter x minus 2. That's the tangent. Now I want to say, okay, my next question is going to be, all right, check it using differentiation or use an alternate method. Check using alternate method. Okay, contact point given of minus 4 minus 1. I now want to work with tangent. F of x, hint, f of x is equal to 4 over x, which is 4x to the minus 1. We always put it in this long line form, correct? Then we find f prime of x, which is 4 times minus 1, x to the minus 1 minus 1, minus 4x to the minus 2, which is minus 4 over x squared, if I'm not going to take a double derivative or a triple. Right? You can see here and now, therefore, y is equal to mx plus c. Therefore, y is going to be equal to, now I say, all right, therefore, the m is going to be at what point? X is equal to minus 4. So therefore, m is going to be minus 4 over minus 4 squared, which is then going to come out to be minus 4 over 16, which is equal to minus 1 over 4. And I end up with minus a quarter x plus c, and use the contact point to find c. So I say my contact point is going to be minus 1 equals minus a quarter times x, which is, that's m. X is going to be, in this case, Let me just look, minus 4 plus c. Minus 1 is equal to minus plus 1 plus c. C is equal to minus 2. Y is equal to minus a quarter x minus 2. And we have checked it using differentiation. Okay. We're going to now carry on with more. I've got quite a few pages of examples that we're going to do. And we're going to start looking at cubic graphs. In the next session, we're going to talk through, in fact, no. What I will do is I'll rather just carry on with this section quickly over here, because we've got about 4 or 5 minutes and it won't be there. I'm just going to show you something. Example. We've been finding the derivative, the first derivative, okay? And that's giving us the slope at any point. We're just going to turn it around. Remember this y equal to ax squared plus bx plus c. Let's find dy by dx of this. Please remember when I do this, this, and this are constants. They are numbers. So when I differentiate, this is going to be a times 2 times x to the 2 minus 1 plus b x to the 1 minus 1, x to the 0 is 1. Therefore, the derivative of this is going to be equal to 2ax minus b. Now, put dy by dx or f prime of x equal to 0. Remember we had a derivative plus a derivative minus. What if it's 0? It means that the slope is flat. That's what the line looks like. It's parallel to the x axis. If we do that, we're obviously going to find something interesting. So we say 2ax minus b must be 0. Therefore, 2ax equals b. Therefore, x equals plus b minus b over 2a. What is this? This is the turning point of a parabola. This is the x coord of the turning point of a parabola. Thus it means that when we find the derivative and we put it equal to 0, we are finding a turning point of a parabola. Or, turns out, the turning point of anything, we call them the stationary point. Let's just have a look over here. I just want to move this up a bit, put in another one. Just let's have a look at a simple parabola. I've made it easy. Over here, the m is 0, therefore the f prime of x must be 0. On the other side over here, you can see that f prime of x over here is going to be greater than 0. On this side, f prime of x is going to be less than 0. This is negative, and the other side is going to be, red is positive. Therefore, you can see that as the slope gets closer to the turning point or the stationary point, we're actually calling it a stationary point. I'm going to call it in blue A because on this side it's going positive gradient, positive, and this it's getting less and less and less until I come to that point where the slope of the line, the gradient, is 0. Then it turns and it goes down the other way. We then say, just a little thing, let's have a look at this. We say if f prime of x is greater than 0, the function is increasing. If f prime of x is less than naught, the function is decreasing. And the last one is we say if f prime of x equals 0, it's a stationary point. Okay. So basically that brings us to the end of this little section. All we have to do is know this piece here, and you'll find is it where show where a function is increasing or decreasing, all right? And you just look at the derivative, and before or after it's going to be increasing or decreasing. Or what about this one here? Just take it up slightly. I have got over this side, okay, there's my turning point. There, f prime of x is 0, but on the, I can say f prime of x over here is less than 0. The other side, green, I say f prime of x is greater than 0. It's positive. Therefore, this is an increasing function. And the opposite side, the red side, I say this is negative. Therefore, it's a decreasing function. And you can do that with pretty much anything. The next section is going to be the cubic graphs, and I'll leave that for that. Thanks for watching. I did go a little bit over, but I think it was just good to just finish that. We're going to talk more about this increasing, decreasing, and stationary point in quite excessively, in fact, when we get to these. Cheers. We'll chat again. Bye. Have a good one.